right. Good morning, everybody. Today is Monday, December 4th, 2017, and this is Before the First Cup with Jules here on UCY.TV. Happy Monday, everyone. It is a chilly 34 degrees with fog and mist per AccuWeather here in upstate New York. So where do we leave off on Friday? We titled the show CRISPR Human Clones. Hold on one second. I think I have the wrong show. Hold on. Wait a minute. My mistake, but it is a Monday. But I think that was Thursday's show. Hold on. No, it isn't. The first. Hold on, let me look at the calendar. The first was Friday. All right. CRISPR Human Clones, IQ DNA, DIY biohacks, gut recording, and ultrasound. And we looked at some crazy biological hacking that was going on utilizing CRISPR, some of the things they were doing in China, some of the things that they were doing DIY in mommy's back bedroom. We ended the show with a story that looked at brain hacking utilizing ultrasound. And I think today we are going to take a look a little bit more at utilizing different types of signalings and how they can use that to manipulate biology. One of the things that we have looked at before is cyborg insects. We looked at that dragonfly eye project a while ago where they had little electrodes stuck into the spinal column of this dragonfly with a little backpack on. And with optogenetics, flashes of light, we're going to look at that a little bit today, they could direct this dragonfly to turn right or left. Well, now, I saw a story that came out November 28th, 2017, from IEEE Spectrum, Controllable Cyborg Beetles for Swarming Search and Rescue. What? Oh, yes, we're going to have cyborg swarms of beetles to come find you when we have an earthquake. Robotics tries very hard to match the agility, versatility, and efficiency of animals as they mimic them. The Robo bees with the Weiss Institute of Biologically Inspired Engineering. Some of the robots get very close in a few specific ways, but we are still chasing the dream of robots that can match our biological friends. One way of getting around this problem is by leveraging biology to design robots. But a more direct approach is just to make the robots themselves mostly biological. And don't think that isn't going to be us someday in the future, because they are working on invading our brains right now. We've reported on this in the past in the context of flying insects, but new cyborg beetles from Nanyang Technological University in Singapore is the smallest and most controllable yet. Here's how the Singaporean researchers, led by Professor Hirokata Sato, described their work in a recent paper. It is possible to use a living insect as a platform to develop living insect machine hybrid robots. Living insect machine hybrid robots. Such a hybrid retains the complex structure of the insect's rigid exoskeleton, compliant joints, and soft actuators, as well as the insect's locomotion capability, and it does so while enabling high controllability and low power consumption. Such an insect hybrid robot is made of a living insect platform with a miniaturized electronic device attached on it to control it. By using the insect itself as the robot, researchers bypass the complex process of designing and fabricating the robotic body, using the insect's muscular system as soft actuators and flexible joints and nervous system as a part of the control system. Ding, 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 ding. They are working on this for humans, and we're going to look at a few of those technologies. So this beetle in particular is a type of a darkling beetle. It is small, 2 to 2.5 centimeters, lightweight, about 0.5 grams, and it lives for about 3 months or so, which is a long time for a little bug. A backpack of electronics interfaces with the beetle's antenna, and when the antenna are stimulated with an electrical pulse, it activates the beetle's built-in escape mechanism, fooling it into thinking that it is running into something and causing it to turn. The advantage of doing it this way, as opposed to a direct nerve stimulation or muscle stimulation, something that researchers have also experimented with, is that the beetle's brain is still in charge of controlling its limbs such that it'll respond to high-level controls with adaptive gaits, and as such, making locomotion a much simpler problem to solve. With just 2 coin cell batteries, the cyber beetle can be controlled for up to 8 hours, which is long enough for it to travel over a kilometer at an average speed of 4 centimeters per second. The key to effectively controlling an insect and not a human, at least not yet, with these methods is that the response to the antenna stimulation can't be binary, since you'll end up with a level of control that would be too coarse to be useful. By changing the frequency of the stimulation, remember they've been working on all kinds of different energy technologies, the researchers were able to modulate how sharp of a turn the insect took. Increasing the stimulation frequency also increased the insect's turning rate with a success rate of over 85%. Stimulating both antennae at once caused the insect to back up, and it moves forward by default, giving you just about as much control as you can hope for. I mean, how nuts is this? And they were already messing around utilizing technologies in mice to make them turn right or left in a maze. And I think that was using optogenetics of some kind. And there were videos of little electrodes or fiber optic cables implanted directly into their brains. So it says, our giant cyborg beetle mainly relies on neuromuscular stimulation of direct flight muscles for control and leg muscles for the forelegs for walking control. Ideally, stimulating the muscle would be more precise than we can perfectly control the individual legs, but it costs more in implantation and computing to plan and stimulate the individual muscles for walking. Antenna stimulation is simpler and easier than stimulating all of the individual muscles, thus it helps us to simplify the hardware and the control system a lot. Hopefully in the near future we can control the cyborg beetle as precisely as any other artificial motor. Remember yesterday we read about some living therapeutics, and we read about being able to turn bacteria not only into recorders inside of the body to be able to record what is going on, particularly in the gut, but also to be able to produce medications to be able to influence what is going on inside of you. We are getting to territories now that are beyond science fiction. All right, so now we are going to hit a story that came out on November 29th, 2017. This was 5 days ago. This is a story that was inspired from shows that we did here on Optogenetics. I co-wrote the story with a listener, and we got it published, so I think this is pretty cool. It's titled Optogenetics, a virtual reality system for controlling living cells. If you remember, we've looked at this a couple times before. This is using different frequencies and flashes of light on some genetically modified neurons that are now sensitive to light to turn brain switches on and off. And we're going to look at that with ultrasound as well. Neurostimulation through light-sensitive proteins for biological manipulation. So not only can they turn you right and left with electrical zaps, but they can turn you right and left with flashes of light. Our brains communicate with electrical and chemical signaling, but scientists have discovered that light stimulation could hold key potentials to manipulating neuronal communication pathways that influence motor control, sensory perception, memory, neurochemical production, and mood, or a cellular virtual reality, as a report from the Journal of Cell Biology describes it. Now, if you remember, we also looked at optogenetics before in regards to some of the research the military was doing to be able to remove memories from PTSD events and to be able to implant better memories in the not-too-distant future. So who is interested in optogenetics? With the rollout of the White House's $300 million brain initiative in 2013, interest in uncovering the secrets of the human brain has accelerated and now includes many government agencies, public and private partnerships, as well as universities. Dating back to at least 1971, optogenetic research has matured enough to gain the attention of organizations such as the National Institute of Health, DARPA, and IARPA, who are exploring the role that light-sensitive cells can soon play in a field surrounding neurobiological, including physical and mental health, machine-human interfacing, and artificial intelligence through reverse brain engineering. How does optogenetics work? Well, currently optogenetic experiments rely on extracting opsins, which are light-sensitive proteins that typically come from algae, which can be introduced to mammals by methods including injection, and yes, that would be injection to the brain, or infection with that adenovirus, the same adenovirus that we had looked at before that they were utilizing. They were inserting CRISPR inside of it and then infecting cells with that adenovirus that is very much like the common cold, so it's easily transmissible, and you can catch it pretty easily, though I was reading you can catch it only once. Once delivered into an organism, opsins can be expressed in the eye, the brain, or skin cells, allowing their light sensitivity to be remotely activated or silenced with time pulses of light in different color wavelengths across the light spectrum that can target multiple bodily systems and cause a variety of biological effects, not just turning right and left. Researchers have suggested, however, that inducing opsins into an organism may not be a long-term requirement, as methods are now sought for using optogenetics on mammalian cells that respond naturally to light, such as those in the human retina. Now think about it, as we are glued to our devices and we are staring at these lights, what's it going to take when there's a little bit of artificial intelligence on the back end? Bloop, let's dial up a flash to make Johnny calm. Bzz, 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 bzz. The flashes of light come through, and all of a sudden Johnny gets really mellow for a little bit. Current capabilities and interests as part of the Brain Initiative, scientists have been working on neuronal barcoding. We've talked about that. That's some of the stuff that Georgie Porgy Church is working on for IARPA, and completing a detailed online brain atlas for researchers, and that would be the Paul Allen Institute for Brain Research. And this is hoped to eventually provide a detailed circuit diagram of every neuron and synapse in the brain, which would allow various neuronal patterns to be identified so they can be triggered for the desired effect. If targeted precisely enough with the appropriate light, it is thought that optogenetics could be used by manipulating neural circuits involved with pain, fear, reward, wakefulness, and social behaviors. In one study, and we've read about this one, for example, mice were infected with a virus, and that would be that adenovirus, which then made their neurons sensitive to blue light. Blue light turns on, yellow light turns off. Scientists then use that light pathway to activate their predatory behavior. Remember, this was how they were using the laser light from some sort of fiber optic embedded in their brains to turn on the killer behavior of mice. Quote, the researchers used a tiny fiber optic to shine a blue laser on the oblongata, and this promoted the animals to tense their jaws and their neck muscles. And it is not just physiological, it is hunting, biting, releasing, and eating. Those are motor sequences that require a lot of information, says an MIT neuroscientist. In 2015, and this was something that we learned in the research, optogenetics was combined with CRISPR to develop a set of photoactivatable tools that enables the editing of an organism's genome through the external use of light. Said tool can control the location, timing, and reversibility of the genome editing process, whether that be activating, repressing, or modifying a gene. Optogenetics is also mentioned as an integral feature of the DARPA-funded Neural Engineering and System Design Program, more affectionately known as the NESD, a program which is a joint effort between 6 teams who are aiming to create an implantable neural interface over the next 4 years that is capable of high-resolution brain-to-machine communication. Such advancements, for instance, could facilitate the development of a mind-controlled prosthetic featuring touch sensation like the DARPA-backed Luke arm, which was previously known as the DECA arm. In the past, DARPA has looked to use optogenetics as for memory manipulation techniques for treating veterans with traumatic brain injury and or PTSD through memory restoration and deletion. And most recently, during a November 2017 mental health conference in Washington, D.C. with 30,000 attendees, and we mentioned that one when it happened. Optogenetics was noted for having quite an impact on studying the brain. According to NPR science correspondent John Hamilton, the technology has allowed aspects of human mental health disorders to be reproducible in animals, aiding the mapping of neuronal circuits involved with issues such as depression. So clinical trials and future technologies, companies interested in the application of optogenetic technologies have begun to emerge over the last decade, particularly since the FDA approved the technology in 2015 for use in treating an eye disorder known as retinitis pigmentosa. The approval prompted a clinical trial, and optogenetic developments have since been used to restore partial vision in patients who were described as being profoundly blind. Chronic pain management, epilepsy, and Parkinson's are also among the health issues that researchers are experimenting with addressing through optogenetics. The technology, so they're going to get into your brain, flash some lights, and they will cure you. Technology is also contributing to other areas of research such as sonogenetics, and this is going to lead us to our next story, which uses low-pressure ultrasound to activate ultrasonically sensitized neurons. This is another area of interest for DARPA, which has funded Columbia University's endeavor to stimulate neurons using ultrasound and believes it could eventually lead to a magnetic version of their technology called magnetogenetics, and we've seen quite a bit of that. To investigate the use of therapeutics to investigate the therapeutic use of optogenetics, acoustics, and electromagnetic fields, DARPA launched the ElectRX program in 2015. We've talked about that one as well, which is capable of stimulating, modulating, and monitoring the body's peripheral nervous system, and that would be connecting to that vagus nerve. The research agency is also exploring how artificial intelligence could be used in closed-loop brain implants, such as the ability to detect patterns associated with mood disorders, and we have a story on that one coming up later on. With enough progress, it is believed that optogenetics and its surrounding bodies of research may open the door to real-time brain mapping and biofeedback technologies, which could be used to treat all manners of ailments on the fly through closed-loop neuromodulation signals coming to and from an implanted device, ultimately eliminating the need for pharmaceuticals. Right. Let them directly into your brain, and you won't need to take a pill, Johnny. This is just insane. So let's look quickly at the ElectRX. The ElectRX program aims to establish a new biomedical therapeutic capability to improve physical and mental health by using targeted stimulation of the peripheral nervous system to exploit the body's natural ability to quickly and effectively heal itself. The nervous system plays a vital role in maintaining all aspects of physical and mental health, and sophisticated networks of sensory nerves continuously monitor your health status and trigger reflective responses in the brain and spinal cord when an infection or an injury is detected. These reflexes normally adjust organ function to initiate and control the healing process. However, some diseases can disrupt healthy functioning of these processes and produce nerve signaling that causes pain, metabolic disorders such as diabetes, and autoimmune disorders such as rheumatoid arthritis. DARPA seeks to establish the underlying science and develop the technologies that will enable artificial modulation of the peripheral nerves to restore healthy patterns of signaling in these neural circuits to treat disease. ElectRX seeks to advance understanding in the anatomy and physiologically of specific neural circuits and their role in health and disease. Fundamental biology efforts will set out to culminate in proof-of-concept demonstrations of feedback-controlled neuromodulation strategies to establish healthy physiological states. And this was from DARPA.mil, by the way. In parallel, ElectRX will seek to develop disruptive biological interface technologies, so you got to love that one, required to monitor biomarkers and peripheral nerve activity, as well as to deliver therapeutic signals to peripheral nerve targets. Technology development will focus on chronic demonstrations of efficiency in biosensing or neuromodulation. Remember, the 21st Century Cures Act talked about some of this. And potential new approaches include in vivo real-time biosensors and novel neural interfaces like that smart neural dust we've read about, using optical, acoustic, electromagnetic, and engineered biology strategies, which we read about on Friday, some of their synthetic biology they are working on, to achieve precise targeting with potentially single axon resolution. Coupling improved physiological understanding with these disruptive technological capabilities could lay the foundation for future systems to manage many acute and chronic conditions through precise, real-time, closed-loop modulation. And if successful, this capability would reduce dependence on traditional drugs and create new treatment that could be tuned like a radio automatically and continuously to the needs of individuals without any side effects. Now, if a side effect is bringing you out of a vegetative state after 15 years, we talked about some of this with Ira Pastor from, I don't remember the name of this company, BioQuark, about that zombie, people had called it the zombie experiment, bringing brain-dead patients back from the dead. Well, here's a story out of Discover Magazine, September 25th, 2017. After 15 years in a vegetative state, scientists partially restore consciousness in a patient. It is generally believed that patients who are in a vegetative state more than a year after experiencing severe brain trauma will not regain consciousness ever again. Their essential bodily functions won't continue, but it is extremely unlikely they will ever be aware of their surroundings again. But as it is often said, never say never. Using an implant to stimulate the vagus nerve, ding ding, the stuff that DARPA's been working on with ElectRX, doctors restored signs of consciousness in a 35-year-old Frenchman who had been in a vegetative state for the past 15 years. As scientists reported in a study published on Monday in September, in Current Biology, the patient could follow an object with his eyes and turn his head on command after 1 month of the brain stimulation therapy. The vagus nerve is the longest and most complex of 12 cranial nerves, stretching from the brain to the abdomen. And remember, we found out in our research a while back that it connects directly to your gut, and that manipulating your gut connects directly to your brain. Vagus nerve fibers branch into every major organ in the body as well, and as such plays a key role in the crucial bodily functions like heart rate, respiration, and the gut-brain connection, to name a few. In the brain, the vagus nerve connects to numerous regions of the brain that together comprise the hot zone for consciousness. Given its important role in the body, scientists have experimented with stimulating the vagus nerve as a means to treat depression, epilepsy, migraines, and Alzheimer's. In this case, scientists led by Angela Singalou for the National Center for Scientific Research in France implanted a stimulation device in the chest of their patient and monitored his brain activity over a 6-month period. After a month, they noted consistent improvements in general arousal, sustained attention, bodily motility, and visual pursuit. Recordings of his brain activity also showed that the man produced brainwaves called theta signals, which is a sign of limited consciousness that is not present in a vegetative state. With those stronger theta signals were also occurring in a parietal lobe of the brain, which is the region that integrates sensory information to provide a basis for perception. Scientists claim that after years of being in a vegetative state, their intervention restored a minimal state of consciousness in this man. No, it wasn't a full recovery, but the researchers say that their work represents a step in the right direction and shows that there is hope for limited recovery, even in the most severe cases of brain trauma. Well, I wonder what type of life this guy's going to have now that they woke him up. This is pretty nuts. So while this is a great advancement, advancement. What is the end goal? Clearly, we wouldn't put thousands of people on life support for tens of years just to restore minimal consciousness. So is this a story just to boost investment to the doctors and the hospitals that achieve this? Well, I appreciate that we could extrapolate this to a case where it is needed sooner, say after a few weeks or months. But I would love it for folks to write, who are writing articles, to probe deeper into why and who are in this scenario. That was somebody's comment, but still, that's good. And he has the same question I did, like, to what end you're going to bring brains back from the pretty much dead? How is that going to end up for those people? So now let's get back to where we ended on Friday. Looking at ways to manipulate the brain, we looked at light. Now let's look at sound. How bursts of ultrasound can be used to flip switches in the brain. It sounds something like out of the beginning of a Stephen King novel. A protagonist bolts up in his bed, his unsuspecting brain picking up ultrasound waves crashing in the air, and these waves have the power to fry his delicate neural tissue, but instead they silently spark his neurons into action. Horrified, the man watches as his arm pulls back the sheets as if controlled by a puppeteer. And using extrasensory sound waves to alter someone's action sounds like a classic sci-fi trope. Yet last week at the Society for Neuroscience conference in Washington, D.C., and that's the very same one that they talked about optogenetics, two teams of scientists presented a proof of concept data showing that acoustic mind control may be possible. In both mock monkeys and sheep, teams delivered ultrasonic waves across the skull to a brain region the size of the single grain of rice. And shockingly, the sound waves interacted with the electrical hum of neurons in the brain, increasing their activity. By focusing the waves on the brain regions that control the eyes and the legs, the scientists could ping-pong monkeys' gazes from side to side and move a sheep's hind legs. Of course, playing animal puppeteers isn't the actual goal, and like other non-invasive technologies, and that's what a lot of these are now, ultrasound lets scientists affect select areas of the brain, and like flipping a light switch, no pun intended, scientists can then explore what happens to our minds when certain neural circuits are turned on and off. The advances presented today help expand what is possible with brain stimulation, says Dr. Helen Mayberg, a neurologist at Emory University, who pioneered using deep brain stimulation for treating depression. These open new ways of viewing and probing the brain to improve our understanding of feelings, thoughts, and actions, she explains, and we should be looking forward to it, yeah, or not. Mind control has an undeniably sinister undertone, no kidding. But in reality, methods that allow scientists to tweak the bustling neural pathways in our head are used for good, or should they hope. Like transcranial magnetic stimulation, the poster child for brain stimulation. By waving a magnetic wand shaped like a number 8 over various regions of the brain, scientists can target wonky circuits that go awry in a variety of mental disorders, including depression. Scientists adore non-invasive ways to manipulate brain cells, and for good reason, compared to deep brain stimulation, which involves directly implanting electrodes into target sites within the brain. Transcranial stimulation, magnetic stimulation, is much safer and easier to implement. But the magnetic waves do have two giant pitfalls. For one, they skim across the surface of the brain, and this limits their power mostly to circuits within the cortex, missing crucial structures such as those for memory, motivation, and reward. For another, they are hard to target. For example, transcranial magnetic stimulation is heavily influenced by brain structure and size, so how activity spreads from one site of stimulation is an open question, and this makes it hard to link a behavioral outcome to a targeted brain region. Though I watched a video last night that was showing how optogenetics was really good at mapping behavioral outcomes to the targeted brain region. Like many discoveries, focused ultrasound stimulation, more affectionately known as FUS, popped into scientists' radar for an entirely different reason, and that would be for epilepsy. It is used to make lesions in the brain, explains Mayberg. And in epilepsy patients where the only treatment option is to remove the seizure-laden brain region, ultrasound acts like a surgical blade to slice away the problem area. Now, we should find that concerning that ultrasound can do that to a brain. I started thinking when I was originally reading this story, what about the fetus that is growing inside of a mother that they do multiple ultrasounds on during very early stages of development? How is that affecting the baby's brain? I know at one point they had pointed to ultrasound as a potential cause for autism and for the increase in autism, but I would be very concerned that they're talking about using ultrasound as a surgical blade, and this is quote, to slice away the problem area in the seizure-laden brain region. So this got scientists thinking, rather than damaging brain tissues, can we lower the intensity and instead use ultrasound to change its activity? So the answer, according to initial experiments in neuronal cultures, is yes. Way back in the 1990s, back in the golden days when no one was really watching what we were doing, the team sliced up living tissue from a mouse's hippocampus and pulsed it with 500 kilohertz sound waves, which is about 25 times too high for a human to hear. These waves depressed activity in some circuits while boosting firing in others. Subsequent studies in mice corroborated these initial results, and ultrasounds can alter neuronal activity even when delivered outside of the mice's cardboard-like skulls. But it can also penetrate our thicker, sturdier protection to tweak our brain. And in one study, Dr. Jan Kubanek and colleagues at Stanford University pitted ultrasound waves against a mock monkey. Generally, scientists first put animals to sleep before delivering ultrasound to a motor region in the brain. This way, they can link stimulation to response, a leg twitch, for example, without having to worry about the animal's own neuronal activity. But we wanted to see if ultrasound can safely and effectively change the monkey's behavior while he's awake. So his team first trained a monkey on a simple task. It had to look either left or right at a glowing target, whichever appeared first. The monkey received a drop of fruit juice every time he got it right, and he soon learned the task. But then the scientists then added ultrasound to the mix, and when they focused the beam on the left side of the monkey's brain's visual center, which controls the right eye, the monkey began looking far more often at the right target, even if it wasn't the correct response. Shifting stimulation to the right side of the brain had the opposite effect. The monkey began looking far more frequently to the left. These results were significant and reproducible, but this stimulation didn't cause any obvious signs of brain injury when scientists later examined the region, hopefully not under a microscope. Poor monkey. The promising results, given that ultrasound's original use was to zap diseased tissues to smithereens. Yeah, I'd say so. So it isn't necessarily a surgical blade. It can be used for one if they wanted to, but it also can be used to influence motor function. Kubanek's results bolster a previous case study of ultrasound stimulation in human volunteers. There was a generator placed on the scalp, and it delivered a burst of ultrasound waves across a subject's sensory cortex. The beam, similar in size to a finger, poked a brain region that was only a few millimeters wide, much more specific than transcranial magnetic stimulation. The volunteers performed better on a task discriminating between two tactile sensations, but none reported actually feeling any of the effects of the stimulation, causing scientists to ask at the time if the effect was real. While the monkeys, of course, can't report their feelings, Kubanek's study does add evidence to the nascent field that ultrasound is doing something powerful enough to change behavior. So I'm going to scroll down because this just keeps going on and on. And the tools themselves are changing what is possible, says Mayberg, and I think we are now in a renaissance in a fairly short-lived field, and that is being able to manipulate the brain with not only light but sound. And this is coming to a device near you one day. So if you remember, back a few weeks ago, we covered a story about Internet of Things devices, including those such as Alexa and Google's Home, as well as Siri, can be hacked using inaudible ultrasounds. Well, if these devices can be hacked utilizing ultrasound, and then we can use ultrasound chirps to hack our brains, where does that leave us in the future? This is out of The Verge, TheVerge.com. September 7th, 2017. Inaudible ultrasound commands can now be used to secretly control Siri, Alexa, and Google Now. It is an effective hack, but unlikely to do much damage in the real world, unless, of course, they flip switches in your brain. Is your digital assistant taking orders behind your back? Well, scientists from China's Xinjiang University have proved that it is possible, publishing new research that demonstrates how Siri, Alexa, and other voice-activated programs can be controlled using inaudible ultrasound commands. This provides a new method of attack for hackers targeting devices like phones, tablets, and even cars, or even your brain. But don't get too worried. The technique has a number of key limitations that means it is unlikely to cause chaos. First, using ultrasound as a discrete form of digital communication is actually pretty common, is pointed out in a Fast Company report on the topic. Google's Chromecast and Amazon's Dash buttons both use inaudible sounds to pair with your phone. And advertisers also take advantage of those secret audio freeways, broadcasting ultrasonic codes into TV commercials that work like cookies in a web browser and track your activity across devices. Deploying these high-pitched frequencies to hack voice assistants has also been suggested before, but this new work from Zhang Hang provides the most comprehensive test of the concept to date, and really it is impressive just how susceptible modern technology is, and you gotta wonder if that is by design. To carry out their attacks, researchers first created a program to translate normal voice commands into frequencies that are too high for humans to hear using harmonics. In this case, that means the frequencies are higher than 20 kilohertz. Then they tested whether those voice commands could be obeyed by 16 voice control systems, including Siri, Google Now, and Samsung's S-Voice, as well as Cortana, Alexa, and a number of in-car interfaces. The research dubbed their method dolphin attack because dolphins, like bats, use high-pitched noises, such as ultrasound, bounced off of their surroundings as a form of echolocation. Dolphin attack was successful across the board, and researchers were able to issue a number of commands, including activating Siri to initiate a FaceTime call on an iPhone, activating Google Now to switch the phone to airplane mode, and even manipulating the navigational system in an automobile. They suggest that the method could be used for a number of malicious attacks, including instructing a device to visit a website which would download a virus or an exploit, or initiating an outgoing phone call to spy on a victim. It is in a neat bit of extra credit work, they even thought through how to compromise a voice command system trained to respond to only one person's voice. Siri has offered this feature for a while, but it is hardly foolproof. They theorized that if you could get a potential target to say a particular sentence, for example, he carries cake to the city, you could slice up the syllables and rearrange them to form the words, "Hey Siri," like we read about in that Voco Photoshop for Voice application. And then, hey presto, you can issue your nefarious commands at an ultrasonic frequency to target the device. Well, that's pretty messed up. And as with the rest of the research, this method is satisfyingly clever, but a little too impractical to be a widespread danger just yet. For a start, for a device to pick up on an ultrasonic voice command, the attacker needs to be nearby, as in no more than a few feet away. The attacker also needs to take place in a fairly quiet environment. I wonder how far a few feet is for ultrasound. And a dolphin, what if they put an amplifier on it? And a dolphin attack that asks Siri to turn on airplane mode was 100% successful in an office, 80% successful in a cafe, and just 30% successful in the street. And researchers also had to buy a special speaker, albeit a very cheap one, to broadcast the commands, and noted that the attacks sometimes had to be tuned to their target. That's because The frequency responses of microphones differ from manufacturer to manufacturer. For the Nexus 7, however, they found that the best performance came from commands issued at 24.1 kilohertz, although the tablet also responded to other frequencies. In addition to these environmental restraints, it is worth remembering that pretty much all digital assistants respond audibly to any voice commands, so the chances of a hacker controlling your phone without you noticing are slim. Plus, to carry out more impactful commands like telling a device to visit a website or sending money to somebody, you should usually have to unlock your device or confirm the instruction. Researchers also noted that it would be pretty easy to implement a fix. You can just tweak the hardware or the software to ignore commands outside of a certain frequency range. That would probably be a good idea, though. You can't do that to your brain. And all these caveats aside, dolphin attacks show that there are new ways of interacting with technology, invariably inducing new vulnerabilities. And the advent of conversational computing is no exception, and manufacturers may want to look into this sort of hack before the inaudible whispering campaign against them starts up in earnest. Now, that brings up a lot of other issues about voice activation, which we have talked about before. Voice activation and you talking to one of your Internet of Things devices, we have discovered in our research that they are able to garner a lot of information from just the sound of your voice, like diagnosing diseases and mental disorders. There was good old Tommy Incel was working on trying to find ways to diagnose disease with the sound of your voice. So that could also be a potential dystopian nightmare of our not too distant future. Well, I ran across a program this morning that I don't remember seeing in the past. This was from February 7th of 2017. It's called Radio Bio. This is from DARPA's own website. What role does electromagnetic signaling have in biological systems? Well, good thing that they are investigating that, since we are pummeled with electromagnetic signals by our ubiquitous devices that surround us on a daily basis. This new program to explore whether electromagnetic waves are purposefully transmitted and received within or between cells, and if so, to then leverage those insights not just for biosystems, but also for communicating in cluttered electromagnetic environments. So they want to hijack cellular communications using electromagnetic signaling. For decades, scientists have wondered whether electromagnetic waves may play a role in intra- and intercellular signaling. Maybe they should have figured that out before they launched cell phones worldwide and Wi-Fi routers. Researchers have suggested since the 1960s, and I bet you some of that research was at Bell Lab, for example, that terahertz frequencies emanate from cell membranes. And you remember we read a study out of Los Alamos where they had warned that certain terahertz frequencies can also rip apart DNA. So that would be pretty frightening. But they have lacked the technology and the tools to conduct reproducible experiments that could produce whether electromagnetic waves constitute purposeful signals for biological function or if they are merely background noise. With recent advances in technology and modeling and probably artificial intelligence, experiments can now be possible to test their signaling hypotheses. DARPA's Radio Bio program, announced today, February 7th, 2017, seeks to establish its purposeful electromagnetic wave signaling between biological cells, and if evidence supports that it does, to determine what information cells are transferring. The validity of existing and new electromagnetic biosignaling claim requires an understanding of how the structure and the function of microscopic natural antennas, so not biological ones like we saw in cyborg beetles. These would be biological ones in cells, are capable of generating and receiving information in a noisy spectral environment. Of course, there are many ways that DARPA could use this in the military-industrial complex as well. There are so many complex interactions within and between cells, so determining if electromagnetic waves, which could be high or low frequency, could somehow play a role in transmitting and receiving meaningful insights through what might be an ion-rich, and we found out That is how they are manipulating brain cells in optogenetics. They are using what they call ion gateways for calcium and potassium or one of the salts or something to be able to turn switches on and off in the brain. But meaningful signals through what might be ion-rich aqueous solutions is a significant challenge, says Mike Fitty, DARPA program manager. And if we can prove that purposeful signaling is happening, the next step would be to discover how that process might work. And this insight could eventually lead to a broad range of technologies important in biology and manipulating biology, as well as new small antenna designs and other innovative concepts for communication systems that we are stealing from the biological world. Fitty is quick to note that radio bio is a fundamental research effort, and even if the program proves that electromagnetic signaling occurs between cells, applications would likely be many years away. The program envisions 2 24-month phases. During phase 1, performers will be asked to theoretically model and simulate hypothesized electromagnetic signaling pathways and then experimentally test those theoretical predictions. In phase 2, the goal would be to independently develop test beds to replicate, confirm, and demonstrate the pathways modeled in phase 1 and reveal design principles potentially relevant to biological and other applications. One of the greatest challenges of the program will be to develop theoretical and numerical models that can describe the properties of a near-field, time-varying, sub-wavelength size biological structure that functions as an antenna, says Fitty. And to overcome such difficulties, Radio Bio seeks expertise in antenna design, theoretical and structural biology, biochemistry, and other related disciplines. We've talked before about how our bodies are just big antennas, and it sounds like now they are going to try to put some science behind that. DARPA's radio bio program seeks definitively to establish if purposeful signaling via electromagnetic waves between cells in biological systems exists, and if it does, to determine what information is being transferred and how, which could inform strategies for developing future novel communication systems in cluttered electromagnetic environments. Now, I came across this story about a week ago, but I really didn't have a place to insert it. And then I ran out of time on Friday, but this seems like as good a place as any. This is out of IEEE Spectrum, dated May 26, 2017, titled Radio-Controlled Genes. Okay, so they can control a certain gene with radio frequencies. Peter Parker, and this is the second time I've seen Peter Parker mentioned in an article, gained the ability to sense imminent danger thanks to the bite of a radioactive spider. But now in real life, researchers in Baltimore have enabled a rat brain to sense electromagnetic fields thanks to the gene of a catfish. Many animals, bees, birds, lobsters, and newts, just to name a few, can sense the Earth's weak magnetic field, but just not humans. But there is some debate over that exclusion. Yeah, maybe with long hair. We talked about that one a long time ago. A newly discovered gene belonging to the glass catfish appears to give cells the ability to respond to magnetic fields, and it can be used to non-invasively manipulate brain and heart cells. The researchers say this technique opens the possibility to creating wireless biological pacemakers, as well as treating epilepsy, or even constructing a brain-machine interface that could use electromagnetic signals to communicate with human cells. Well, go figure. Who would have thunk they'd be working at something like that? I mean, guys, this stuff is just to the point of really insane science fiction. Gallet Peld, an associate professor at the Kennedy Krieger Institute, as well as Johns Hopkins University School of Medicine in Baltimore, where they have the largest brain database on children, will present this work on Sunday, the 8th of May 2017, at the International IEEE EMBS Conference on Neural Engineering in Shanghai, China. Scientists have previously identified genes involved in electromagnetic sensing in pigeons as well as in bacteria, And many of those genes work together to form complex molecular complexes that sense the magnetic fields. But this new gene, this is the first that's been found in a fish. This is the glass catfish. It is unique because it works on its own, and it is not associated with the formation of such complexes. Peld and his colleagues originally found the gene by inserting various bits of DNA from the glass catfish into frog eggs and then seeing which eggs responded to a magnetic field. They identified just one gene with that effect, and they named it the electromagnetic perceptive gene, more affectionately known as the EPG. How the protein encoded by EPG actually senses electromagnetic fields remains a mystery. We don't exactly know what the protein is doing, he says. This is from Asif Gilad, an associate professor of radiology at Johns Hopkins Medicine. But they do know the effect that when the protein binds to the surface of a cell, it causes a flood of calcium into that cell. Again, that's some of that ion gate signaling that they are using in optogenetics. And for many cell types, including neurons and heart cells, that gush of calcium activates the cell, causing it to fire or to beat. The team inserted this EPG gene into groups of brain cells, and then they were able to wirelessly activate those neurons with an electromagnetic field. Oh my God. They also inserted this EPG gene into the living brains of rats. And I bet they did that with an injection, but we're going to find out in the future they're going to be able to do it with an adenovirus as well. This is important because Gilead hopes that the technique will someday be used to activate select parts of the human brain to ease conditions related to misfiring neurons, such as epilepsy and depression. They are coming for your brain. Currently, doctors use invasive techniques such as deep brain stimulation to try to alleviate such illnesses. But with this EPG, they might instead deliver the gene via gene therapy or stem cell transplants into a patient's brain and then wirelessly manipulate the cells. There is also potential for heart conditions where a pacemaker made of cells expressing EPG could be controlled wirelessly, and it would not have to be replaced every 10 years like a traditional electronic pacemaker. This ability to remotely control neuronal activity is big, says Gilad. Still, he notes that this is a very experimental concept, but remember, for many different technologies, light technology, ultrasound technology, and now some sort of magnetic technology with gene therapy is all going to be able to flip calcium ion switches in your brain, turning things on or off. Speaking of experimental, let's go back to Spider-Man. Could the tech be used to give mammals, let's say humans, a sixth sense? Well, maybe. I don't know, says Gilead. Right now, the team has only identified a single part of the catfish's electromagnetic sensing ability. But once more is known about how it does work, well, yeah, maybe sometime down the road, he says, people could have their own GPS, he says with a laugh. But for now, the team is busy looking deeper at the fish's system and investigating more immediate uses for this gene. So to add insult to injury, there was another story out of IEEE Spectrum, this one dated November 28, 2017. We now have simultaneous touchless monitoring, non-invasive of course, of several patients' vital systems all at one time. Hospitals, or maybe someone spying on you, may soon be able to keep tabs on the health of a dozen people at a time from afar. Researchers have come up with new touch-free ways for monitoring heart rate, blood pressure, and breathing of several people at the same time. If you remember, we covered a story a while back about MIT Technology. MIT Technology Review had a story, and I think it was MIT researchers were able to use your wireless routers and bounce the signal off your body to be able to determine the emotions of people in the room. This is a small RFID tag placed near the body, say in a shirt pocket or in a wrist cuff, is all the system needs in order to read these vital signs. In addition to being more comfortable for patients, the technology can make it easier, faster, and cheaper. Those are the things we need. This is how this technology is invading our lives. Easier, faster, cheaper for hospitals and care facilities to monitor the health of residents. continuous monitoring of vital signs can be a nuisance. If you remember, we looked one time at a place that was selling a unit that was for the cages of rats to be able to remotely monitor their biosensors and their biofunctions. Well, that's what this is going to be able to do. You're going to have to get health insurance in the future. And in order to get health insurance, you're going to have to carry around this little RFID tag in your insurance card, maybe. Uh-oh. Aren't they putting those into all of our cards to make them hack-proof? Yeah, well, it's the same technology, RFID. Anyway, in addition to being more comfortable for patients, it can make it easier, faster, and cheaper to monitor the health of residents in hospitals and care facilities. Continuous monitoring of vital signs can be a nuisance. It requires electrodes stuck to the skin and a tangle of wires or a tight arm cuff and sitting still and waking you up at 4 in the morning. I remember wearable sensors like wristbands, soft wireless patches, and temporary tattoos, something that Regina Duggan had talked about, can gather this information, but those might not often be good for options for the elderly, infants, and people with medical conditions. Measuring vital signs without any skin contact is already possible with radio waves. And we have a story on that one. I think I put that, I don't know. I thought I had that here somewhere, but maybe I missed it. And for tracking respiration, the idea is to bounce RF beams off of somebody's body and measure the periodic changes in the reflected signal caused by the person's breathing. But measuring the heartbeat is just a little more challenging. Oh, hold on. I clicked on another link, and it instead of opening a new tab, it moved me to another one. But measuring the heartbeat is more challenging. What is more, says Edwin Ken, professor of electrical and computer engineering at Cornell University, is that this method is very vulnerable to movement in a room. Another person's moving on the other side causes a lot of interference. So Ken and his graduate student, Xinhuan Hui, had devised a method that relies on near-field coupling. The near field is a region of the electromagnetic field right around an RFID antenna, and I've been seeing a lot of this near-field communication with what they are calling now a PAN, or that would be a personal area network, and that is being used in a lot of this medical technology like Fitbits talking to your cell phone and things of that nature for small distance communications that potentially would be a lot more private than long-distance communications. The system requires a small antenna and an RFID tag to be placed near the chest and the wrist. So what happens once DARPA figures out how to read the small antenna inside of all your cells? They could be doing a live, real-time cellular 24/7 monitoring on you just by a little patch on your arm. They could be up to 10 centimeters away from the body, and an RFID reader's